and I'm going to start sharing my screen. And before we do anything else, last couple days I've had a couple of people, ask me to meet with them one-on-one, and most of them have come and met me in my office hour. And so I just, for those of you who might not remember from the first day of class, the information about my office hours, because it's through Zoom, I put it in this folder, Zoom information. And when you click on it, you get a Word document. And when you open that Word document, it has my office hours, and it also has the Zoom link for my office hours. If you ever need to meet with me one-on-one, we'd have to set that up at an agreeable time outside of office hours or outside of class. I will also use this link. I'll try to remember to send it to you if that is the case. With this link, I'm just like with the link for class, I hope to be able to use the same link for the entire semester. And I did not attach a password to it, which I know makes it compromised security-wise. But I think it makes it easier for you guys to get in, just one last hoop that you need to jump through. Is everybody all right with where the office hours stuff is?
Yeah.
Another thing I wanted to show you was in a couple of classes, people were questioning attendance. And if you look in my grades, in the grade book, and it isn't working for me, but I could have sworn for you, and it might not be working for me because I'm not a student, so I don't have any attendance. That should be in blue, and if you click on it, it should give you a list of the days you were counted present, absent, or late. If you have a question on that, please talk to me outside of class time if you want it. If you have a question today, I'll hang out for a minute at the end of class, after class. Otherwise, send me an email or talk to me at some point in time if you have questions about attendance. And I'm gonna apologize. Last class I meant to turn off the recording and I hit the wrong button and ended class abruptly. I hope that I don't do that to you guys. I feel so bad about having done that to them. Other than that, stuff in Blackboard, next thing I wanted to look at was the homework and ask, does anybody have any questions on any questions in the homework? And before I do that, this is where I get in trouble, when I get all these toolbars at the bottom of the page. I should open the chat in case people who don't have audio want to ask a question. Does anybody want to look at any questions from the homework?
I don't need help with a specific question, but I would like clarification on instructions.
Sure.
Okay, the only time that we have to put the absolute value around X in our answer is when they don't specifically say X is greater than 0. Is that right? Okay.
If they don't say X is greater than 0, and also if you end up with odd exponent. Because if I have like X squared, it'll be positive no matter what. Right? Okay. Anything else? So everybody's all right with that last homework. Then I'm going to open the start of notes for today. Today's homework 4. It was supposed to be after homework 3, but who knows where I dragged it to. It is Oh dear. It's saying that my internet is unstable. Can you hear me now? Can you hear me now?
You were froze for like a good minute.
Okay, can you hear me? Do you need me to switch to the headphones? Would that help, or is that, what?
Yeah, I can hear you. You just like keep freezing, like you keep glitching.
You know, we just got our internet supposedly fixed. So I don't know if there's construction going on my block. Is it okay now?
It says your network bandwidth is low. I don't know what that means, but that's what the screen says for your camera.
Huh.
Sometimes you stream in like a really small box. At least that's what I'm seeing. I don't know if anyone else is seeing that, but
Okay, let me go down and see if my husband's using the internet, and if he is, tell him to stop. That might help. I'll be right back. Sorry about that. He said he was not online, so I don't know what to tell you. The second computer that I have on for attendance, I'll shut down and see if that helps. Okay, other than that, I don't know what I can do. Does it sound okay now? Hello, can you hear me?
Yeah, I can
It
hear you.
sounds fine. You
Yeah,
did
Okay.
it sounds a lot better.
All right. Let me go back to sharing the screen then. And yeah, we were talking about the quiz is you can take any time after class, and it needs to be done before midnight on Sunday. This quiz I'm giving you 35 minutes for. Hopefully that's sufficient time for everybody. Any questions?
Yeah, what's it on?
It's on what's in P2 and 3, your exponent rules,
All right, thank you.
and radicals. Okay. I don't remember how many questions are on it. Around 10? A little more, a little less. There's about 10 questions on it. All right.
Okay.
Okay, so if that's all right, I think where we're going today, based on the reaction that I got from the other class, they liked this a lot better. Today we're going to start looking at polynomials. And before we look at polynomials, we need a couple of basic definitions. And the first definition is that of a term. And a term we'll define as the product. So since it's a product, we're just multiplying. It's the product of constants and variables. When I look at a term, We frequently talk about its coefficient. And the coefficient of a term is the constant factor remembering that a constant is just a number, something whose value does not change. The other thing we need to know about a term is the degree of a term. And the degree of a term is the sum, which means we're adding. It's the sum of the exponents on the variables. So, does everybody have those definitions down?
Yep.
Yep.
If so, I'd like to look at some examples. For each of these examples, I'd like you folks to tell me what the coefficient is and what the degree is. First one, let's look at 3x. The coefficient is a constant factor, the plain old number. Can anybody tell me what the coefficient is of this one?
3.
3. Beautiful. And the degree has to do with the exponent. What's the highest exponent in this expression on a variable?
1.
1. Beautiful. Next, let's look at negative 5xy. What's the coefficient?
-5.
Negative 5. Now this one has two variables, so we're going to have to add the exponents on the two variables, and when I add those exponents, what would I get?
2.
2. So it's second degree. Beautiful. What if I have 4x to the third? What would you tell me the coefficient is?
4.
And the degree?
3.
Beautiful. Next one, what if I have x to the second, y to the fifth? What's the coefficient on this one?
1.
Beautiful. If there's no coefficient in front, there's an invisible 1. And what's the degree when I add the exponents?
7.
Beautiful. And one last, let's say I have 9. What's the coefficient here?
9.
9. And what's the degree?
1.
Is there a variable in this one?
Would it just be 9?
Actually, the degree for this is 0. That gets us to a constant term. It's a constant term. A constant term has no variable factor. And so that would be like that last example, 9. And since there's no variable, can I think of that 9 as being 9 times 1? And can I think of that 1 as being x to the 0? Because anything to the 0 power equals 1. So if I have a constant term, the degree of a constant term is 0. And now that we know what a term is, we're going to define a polynomial. Poly means many. A polynomial is a sum of many terms. Where the variables have whole number exponents. So I guess some of you might be breathing a sigh of relief. In order to be considered a polynomial, it has to have whole number exponents. So with these, we will not have any negative exponents. With these, we will not have any fractional exponents. When we talk about a polynomial, we want to put it in descending order. Which mean that the exponents decrease as we look at it from left to right. Once it is in descending order, we talk about the degree of a polynomial. And the degree of a polynomial is the degree of its highest degree term so that the degree of a polynomial is the degree of its highest degree term, and the leading coefficient is the coefficient on the highest degree term. So we want them in descending order so that the exponents go down as we read from left to right. Once they're in order, the degree of the polynomial is the degree of the highest degree term. Most often that just means it's the highest exponent unless we have many variables. And the leading coefficient would be that first coefficient once we are in descending order. So can I go on and look at an example, or does anybody still need a minute? We good?
We good.
Okay. So let's look at an example. Let's say I have x squared minus 3x cubed plus 4x to the fifth minus 2. What we'd like to do is we'd like to put it in descending order. We'd like to know what the leading coefficient is. We'd like to know what the degree of the polynomial is. And we'd like to know what the constant term is. So as I look to put it in descending order, what's the highest exponent you see here?
5.
5. So we'll start with the 4x to the fifth. The next highest exponent is 3. So we'll have minus the 3x to the third. The next highest exponent is 2. So we'll have x squared. And then the lowest exponent is 0. Usually if we're in descending order, that constant term should be last. Now that we're in order, the leading coefficient is the first coefficient once we're in order. The degree, so here it would be 4, pardon me. The degree is the highest exponent if we only have one variable. So this would be 5th degree. And the constant term is the constant at the end, the constant without a variable attached, so it would be negative 2. Then give you another one and ask you folks to put it in order. Find the leading, the degree, and the constant. Let's look at 9x squared plus 6x minus 5x to the fourth plus 2x cubed minus 7. I want it in descending order. I want to know what the leading coefficient is. I want to know what the degree is. And I want to know what the constant term is. And I'll give you folks a minute to do that. Does anybody want to tell me what they got when they put this in descending order? Anybody there? Can you hear me?
Negative 5x to the fourth plus 2x to the third plus 9x to the second plus 6x minus 7.
Thank you. Beautiful job. Everybody in agreement with that one? What's my leading coefficient?
-5.
Negative 5. The degree is,
4.
and the constant is
-7.
negative 7. Beautiful. Next one I want to look at is a tricky one. This time let's look at 2x to the 1/2 plus 3x to the negative 1 plus 5. And before you try to do anything with this, you don't really have to. If you see something like this on the homework, there's going to be a little button that asks you to say that it's not a polynomial. Because in order to be a polynomial, we had said that those exponents have to be whole numbers. If I look at this, if I were to rewrite it, that x to the 1/2 means the square root of x, that x to the negative first means I have x in the denominator, and if I have a radical or if I have a variable in the denominator, it's not a polynomial. All right? If those are okay, then some more definitions. We classify polynomials by the number of terms. And so the first classification are monomials. And mono means one, and so they have one term. So an example of a monomial might be something like 3x. I just have a single term. All I see is multiplication. Instead, if I have a binomial, can anybody tell me what that prefix bi means?
2.
2. Beautiful. So it has two terms. So an example of a binomial might be something like a squared minus b squared. It'll be two terms with addition or subtraction between them. Trinomial will have how many terms, do you think?
3.
3. Beautiful. So an example of a trinomial might be something like 5x squared plus 6x minus 1. Beyond those, if we talk about a general polynomial, Sometimes you might see a general polynomial, something, let's say, of nth degree. That means that my highest exponent will be n. I'm leaving a space here on purpose. My exponents will go down. So I might have n minus 1, then I might have n minus 2, and I'm going to keep on going down until I get to that first degree term, and then my constant, which would not have a variable in it. And then each of those are going to have a coefficient. We're going to use a random variable for each of those coefficients. I'm going to call them A, but they're not necessarily the same. So this will be A sub n. This will be A sub n minus 1, A sub n minus 2. This would be A sub 1. And then my constant term will be A sub 0. And so the little subscripts just mean that while I'm using the same variable for all of my coefficients, they're not necessarily all the same number. The subscript just tells me that, this is one for the nth degree term, and so on and so on. So that's just an algebraic expression to show me a general polynomial, no matter what the degree. Once we've got our polynomials defined, any questions so far? Are we all good?
No.
We're good?
Yep.
Okay, great. Then next thing we're going to look at are our operations on polynomials. And the first operation that we're going to find is addition. And addition involves a skill that we have already. All we're going to do is combine like terms. So if I look at a couple of examples, first let's look at, actually I didn't need that parentheses there, the sum of two monomials. Let's look at 3x squared plus 4x squared. And is everybody in agreement that those are like terms?
Yes.
So when you add them, what do you get? 3 plus 4 will be 7. And they're the same. They're like terms. They're the same. They have to stay the same. The sum is the same. So that's 7x squared. Next one, let's look at 12x to the 5th plus x to the 3rd. Are those like terms?
No.
No. So we can't do anything. We're done. Stop there. Next, let's look at adding some larger polynomials. Let's say I have negative 7x to the 3rd plus 6x squared minus 11x plus 3. And I'm going to add to that 19x to the 3rd minus 11x squared plus 7x minus 17. Because we're adding, and there's no number in front of the parentheses, I don't need to worry about distribution. Do I have any like terms? Is there anything that's like with my negative 7x to the 3rd? The 19x to the 3rd? So those will add to 12x to the 3rd. Is there anything like with my 6x squared?
The negative 11x squared.
And so when I add those, I'll get Actually, I don't need to put that plus sign in there. When I add those, is everybody all right if I write that as minus 5x squared? Then the negative 11x is like with 7x, giving us negative 4x. And lastly, the 3 is like with a negative 17, giving me minus 14. That one all right. If so, the next one's a tiny bit different. What if I have something like negative 2x squared y plus xy squared plus 4yx squared plus 7xy squared plus 2xy. Is there anything that's like with the negative 2x squared y?
Yeah, the 4yx and the 7xy on the other side.
I'm thinking just the 4yx squared, because if you look here, the x has an exponent of 2 and the y has an exponent of 1. With this, the one with a coefficient of 7, do you see the exponents are a little bit different? And so this is going to be like with the 4yx squared. And so that's going to give me 2x squared y. And again, those are like because the same variables have the same exponents. Instead, that plain old xy squared will be like with the other 7xy squared. And here the same variables have the same exponents. So that's going to leave me with 8xy squared. And then the 2xy, that's the only one of those terms. So it will just come along at the end. Is that one all right for everybody?
Yes.
Yes, and is my internet still working okay for you guys?
Yes.
Okay, all right. Then next, let's look at subtraction. And if I look at the subtraction of polynomials, way back when I first learned about adding and subtracting like signed numbers, I learned it that in order to subtract, what you do is you add the opposite. And I know a lot of people find it easiest to see that if they distribute a -1 to the polynomial behind the subtraction. So what does that mean? Let's look at a sort of simple example. If I have x plus 2 in parentheses minus in parentheses 3x minus 5, what I've got here are two binomials and I'm subtracting them. So I've got the x plus 2 minus 3x minus 5. And I think of putting a 1 in front of each. In the first one, when I distribute that 1, it's a positive 1. And so that stays x plus 2. In the second one, because of the minus for the subtraction, what I'm going to distribute is not positive 1, but rather -1. So -1 times 3x is minus 3x. -1 times -5 is plus 5. On that first quiz, when we were simplifying expressions, there were some people that went through and did the distribution like this, but somehow after they distributed, they changed the operation. Now we're going to be thinking of this, it still is addition and subtraction. This is like x minus 3x. That's going to give me negative 2x. And then the positive 2 plus the positive 5 is going to give me plus 7. Is that one all right for everybody?
Yep.
Yeah. So I'm going to put up another example. Same general idea, just looks a little bit more involved. And I'm going to give you folks a minute to work on this one on your own.
I have a question.
Sure.
So for the previous example, where it says 1x plus 2, why didn't you bring down the 1? Why is it just x plus 2?
I distributed the 1. When I take 1 times x, when I multiply by x, I don't change what it equals. And so I'm going to just write it as x. If you really, really, really wanted to, you could write that as 1x. But usually when that coefficient is 1, I have this theory. Mathematicians are lazy and they don't like to write. And so if I multiply x, it's like if I took 1 times 2, it would just equal 2. If I take 1 times x, it's just x. So usually, you know, lazy people don't write it.
Okay. Yes. Thank you.
All right. Let's look at 18. Thank you for asking. X to the 4th minus 2x to the 3rd minus 7x plus 8. And that is 4 terms. From that, let's subtract another polynomial with 4 terms. Let's subtract 9x to the 4th minus 6x to the 3rd minus 5x squared plus 7. And I'm going to just leave that one there for a minute and have you folks work on it, and then we'll go over it. How'd I do? Did anybody else get 9x to the 4th plus 4x to the 3rd plus 5x squared minus 7x plus 1?
Yep.
Yep. And again, I've gone through and shown an awful lot of work. As you get more comfortable with this, it's all right if you do some of those steps in your head. What you really have to remember, though, is when you're subtracting polynomials, you have to think of, before I add them, I have to change all the signs. Again, if you take the time to show that distributing -1, for most people, that's enough to avoid careless mistakes. I rewrote the problem instead of just throwing a 1 in there. On your own, you don't necessarily have to rewrite the problem. You can probably just get by throwing that -1 in there. If addition and subtraction are all right, next thing we're going to look at is the multiplication of polynomials. And when we multiply polynomials, we're going to find there's a whole plethora of different things that could happen. The first thing we're going to look at is if we multiply a monomial by a monomial. And an example might be something like if I have 6xy to the 4th, that's all one term, and I'm going to multiply it by 12x to the 3rd, y to the 2nd. I think we've actually looked at some problems similar to this when we developed our rules for exponents. And we said that what we would do is we'd multiply the coefficients. And when we use our rules for exponents, we'll add the exponents on common bases. And so when I multiply the coefficients, that would give me 6 times 12, or 72. When I look at factors with common bases, I'll have x times x to the 3rd, which adding exponents gives me x to the 4th. And I'll take the y to the 4th times the y to the 2nd and end up with y to the 6th. And again, you don't need to write that middle step down. I just put it in to make sure that if anybody's not all that familiar with it, they see it all done out. So let's look at one more. Let's have you folks multiply -8x cubed yz by -2x y to the 4th. And tell me what you get. Anybody have anything yet?
I do.
What you get?
I think it's 16x to the 4th, y to the 5th z.
And I think that's spot on. Is everybody else in agreement? Good job and thank you.
Yes.
Yeah? All right. Then if we're okay with multiplying a monomial by a monomial, the next multiplication that we're going to do is we're going to multiply a monomial by a polynomial. And to multiply a monomial by a polynomial, I'm going to write an example, and I'm betting that pretty much everybody in this class will be able to tell me the trick I need to do. Not the trick, the process I need to do, the property I need to apply. Let's say I have 5x times x cubed plus 3x minus 4, where I have a single term multiplied on the outside by, here I have a trinomial. Any ideas as to what I need to do? Can anybody remember the name of the property?
Distribute.
Yep. So we have to do our distribution. So 5x times x cubed would give me 5x.
5x.
Beautiful. Next one would be
15x to the, or squared.
beautiful. And last one would be
Negative 20x.
got it. And can I go on the assumption that that distribution is well within everybody's comfort zone?
Yes.
Yes. Any questions on distribution? Everybody okay with it?
Yep.
Okay. Then next thing we're going to look at is to multiply a binomial by a binomial. And back in ancient times, we learned it one way and everybody did it the same way. I'm thinking you folks aren't quite from ancient times. And so I'm going to look at this one problem 3 ways. The first way I'm going to look at it is to use repeated distribution. So binomial is 2 terms. I'm going to have A plus B. There's one binomial. I'm going to have C plus D, my second term. My second binomial also has 2 terms. Now, first I'm going to distribute the A. So that's going to give me A times C plus D. Then I'm going to distribute the plus B times C plus D. Now I have to distribute again, giving me AC plus AD plus BC plus BD. And usually they don't remain like this. A lot of times, depending on what you're multiplying, you might have like terms. But at its most basic, do you see how I'm just distributing twice? And when I do it correctly, I should have 4 terms. So we're looking for those 4 terms. Some people, instead of learning it as repeated distribution, has anybody ever heard of FOIL?
No.
Yes.
If you're a FOILer, F is first, O is outer, I is inner, L is last. And so when I look at A plus B times C plus D, when I talk about the first, I talk about the first one from each binomial. When I talk about the outer, I mean the 2 that are on the outside edges, gives me AD. When I talk about the inner, I mean the 2 that are on the inside in the middle, gives me BC. And when I talk about the last, I talk about the last one in each binomial, gives me BD. And I know it's just a silly abbreviation to memorize, but you see how it takes us to the same place in a little bit less work. So that's the FOIL method. And then other class, there were a whole bunch of people who told me they learned how to do it using the box method. Do I have any boxers here?
Yes.
Yeah. With the box method, I'm going to draw a rectangle. On the top, I'm going to write the first one, A plus B. Along the side, I'm going to write the second one, C plus D. Then A times C, C times B, D times A, D times B, and they're all positive, so I'll just go through and add them, and I get that same AC plus AD plus BC plus BD. And so whichever of those methods you use, it's always going to take you to the same place. So I'm not going to say one is better or worse than the other. It's a matter of personal preference, which you use. So let's look at a few examples. First example, I'm going to take x plus 8 times x plus 5. If you're a boxer, draw your box. If you're somebody who just learned how to distribute twice, do your distribution. I'm going to be that person. I first learned it by FOIL, so I'm going to go through and do my FOIL. No matter what method you use, we should all end up with the same 4 terms. The only thing that might differ is the order of the terms, but they should be the same. Did anybody get the 4 terms x squared, 5x, 8x, and 40, all positive?
Yep.
Yes.
And are any of them like?
Yeah.
Yeah, so our final answer will be x squared plus 13x plus 40. I know some of you are getting this real quick because it's something you've seen a lot of times before, but I'm afraid that there's some quiet people that are kind of sketchy on this. Does anybody have any questions on where those 4 terms came from? If not, I want to look at a couple more. Let's look at next example. X plus 2y times 3x minus 4y. And whether you FOIL or box or distribute, can everybody go ahead and get me your 4 terms? Did everybody get those 4 terms? 3x squared, negative 4xy, positive 6xy, negative 8y squared. And when we combine like, we get 3x squared plus 2xy minus 8y squared. That one okay.
Why wouldn't you move the y squared to after the 3x squared?
You could if you wanted to. It doesn't matter. If you wanted to write that as 3x squared minus 8y squared plus 2xy, that would be perfectly fine.
But does it matter? Because in the beginning, okay, just kidding. I figured it out.
Next one looks a little different. Next one, I want to look at x minus 5 quantity squared. Is everybody all right if I say you cannot just use your exponent rules here because there's subtraction in the middle? If you have a binomial or a trinomial or any polynomial that has more than one term being raised to a power, what you need to do is you need to take that polynomial and multiply it by itself. If you're a memorizer, there's a pattern you can memorize. But I've always thought it's most basic if I remember to multiply that binomial by itself. I won't make a careless mistake because now I see that I need, does everybody see the need to either distribute, FOIL, or box? And I'm going to have to get my 4 terms. Here they'd be x squared minus 5x minus 5x plus 25. And I've got like terms in the middle. So that'll be x squared minus 10x plus 25. And so if I square a binomial, my final result should always be a trinomial. Some of you might notice, might have heard in the past, the first term is the first term squared. The last term is the last term squared. And that middle, if you want to memorize a rule, multiply the 2 terms and then double it. The reason we double it is because we have that addend twice. So let's look at another one of these. Let's look at, let's say, x plus 2y quantity squared. And could everybody take that? And remember, you need to multiply it by itself. Could everybody take a minute and tell me what you get?
Like the final answer or like the 4
Yeah.
numbers?
Final answer after you combine.
I got x squared plus 4yx plus 4y.
Squared?
Yeah.
Okay, and that's perfectly fine, that's acceptable. Usually if you're, well, my math lab should accept that. Usually if you're looking at something like the answer in the back of a textbook, the only thing that might look different is it's most normal to put those variables in alphabetical order. So usually you'll see that as 4xy instead of 4yx, but really you're right, it doesn't make a difference, they're the same. But please remember that if you've got that binomial squared, you have to multiply it by itself. People make careless mistakes when they try to come up with shortcuts that don't work. Next one though, I want to look at 2x plus 7y times 2x minus 7y. And this is the one and only case where you can use a shortcut. Let's first do it without a shortcut, either by box or distribution or FOIL. I get 4x squared minus 14xy plus 14xy minus, let's see, 7 times 7 is 49, y times y is y squared. And with this one, when I combine those middle terms, do you guys see they're opposites? And opposites add to 0. And I don't need to show adding 0. So that's going to give me 4x squared minus 49 y squared. And is there anybody else that reminds you of our conjugate pairs when we were rationalizing denominators? I have the same 2 terms. One's a sum and one's a difference. This is the one where we can take a shortcut and take the first term squared minus the second term squared. The product of the sum and difference.
Would it ask us to do that on the MyMathLab?
They're going to say use the rule for the product of the sum and difference to find the product. But quite honestly, whatever method you use, if you need to multiply it out by FOIL or box or distribution, that's perfectly fine. But with this one, if two terms, sum and difference, you should always expect your answer to only be two terms and not necessarily the trinomial or the four-term polynomial you might get. So just, if you can remember the shortcut, great. If you can't, multiply it out. It'll take you a minute longer, but that's fine. But don't be surprised with this when it's the sum and difference that the two middle terms cancel out. All right? So on my math lab, they'll give you this problem, and eventually this is the answer you type in the box. But the middle steps that you do on your sheet of paper, they won't know.
Okay.
Okay. So whatever floats your boat, however you're more likely to do it correctly. Next one is to multiply any polynomial by any size polynomial. And with this one, the two methods that I know are either the repeated distribution or sometimes that same process is done in a vertical method. Or if you're a really good boxer, by all means you can box. So let's look at an example. Let's look at x plus 5 times x squared plus 10x minus 2. Repeated distribution means first I'm going to take the x and multiply it by the x squared plus the 10x minus the 2. Then I'm going to take the plus 5 and multiply it by the x squared plus the 10x minus the 2. Distributing, I'll have here x to the third plus 10x squared minus 2x. Here I'll have 5x squared plus 50x minus 10. And then I think I've got some oh, hello, it would help if I wrote it correctly. I'm sorry, that should be 5x squared over there. Combining like terms, I only have that 1x cubed. I have 15x squared. I have plus 48x, and then the minus 10. So that's the repeated distribution. Vertical method is pretty much the same way, but this is, again, going back to ancient times, the way I learned it. I learned it that if you write the longer polynomial first, and then put the next polynomial below it. Can anybody remember back in pre-calculator days when you had to multiply a multi-digit numbers? First you'd go through and you'd multiply everything by the ones digit. So in the same way, I'm going to go through and multiply everything by the 5. So that would give me 5x squared plus 50x minus 10. Then I'm going to go through and I'm going to multiply everything by the x. X times negative 2 is minus 2x. And when I do it this way, when I get those products, I line up my like terms. So the x times the 10x would give me 10x squared. And that's positive. And then the x times the x squared would give me x cubed. Does everybody see where each of those terms came from? Now, to combine like terms, I'm going to add down, and I get x to the third plus 15x squared plus 48x minus 10. You see, it gives me exactly the same answer. I know personally I was always more comfortable writing them up and down instead of sideways. And same problem if I have a boxer. This box is just going to be a little bit bigger. On the top, I'll put my x squared plus 10x minus 2. On the bottom, on the side, pardon me, I'll put my x plus 5. And then it's the same process. We're going to multiply each term by each term, which is equivalent to that distribution of the x, and then the distribution of the 5. And then when we try to pick out the like terms that we can add, there's only one x to the third. 5x squared plus 10x squared is the 15x squared. 50x plus the minus 2 is 48x. And then we got our minus 10. And so do you see how all three methods take us to the same place? I'm not going to force you to be a master of all three methods, but I am going to ask you to take one and become really, really good at it. I think I have time for one more problem, and this is an example that I didn't get to in the other class, so you guys have a little bit of a heads up on them. What if I have x plus 2 to the third?
Instead of writing it 2 times, you write it 3 times?
Beautiful. So I'm going to go x plus 2 times x plus 2 times x plus 2. And then I have to do a couple of different types of multiplication here. First of all, I have to multiply these two binomials. So those two multiplying will give me x squared plus 2x plus 2x plus 4. Or those two will give me x squared plus 4x plus 4. But then after that, I still have to multiply them by the third x plus 2. And so again, I think I told you guys my favorite way of doing that one is vertically. So I'm going to go ahead and write that vertically. Multiplying by the 2 gives me 8x and 2x squared. Multiplying by the x gives me 4x squared, and x to the third. And if I line them up right, I'm going to add down to combine my like terms. And that would be my final answer. So again, rule of thumb, if you have a binomial or larger to a power, multiply it by itself however many times you need to. Start with your FOIL or distribution or box, and then keep on multiplying. When you're older and wiser, when you get to pre-calculus, you'll find that there's a pattern that you can use to raise any binomial to any power. And so you'll eventually be doing crazy things like x plus y to the 7th. But by the time you get exponents that high, you won't have to do all of this work out. You'll have a formula that you use. But we don't know that formula yet, so I promise I won't ask you to do anything that big. I think in the homework there's maybe one word problem, one application problem. I'm going to ask that you folks try that one on your own. If it's not working for you, don't lose sleep. We'll go over it in class on Monday. Does anybody have questions on anything that we did, or is this all kind of familiar territory for everybody?
Familiar.
Familiar? So can I go on the assumption we kind of went through things, not real slowly, but I think most of you